Good afternoon, all. I do believe I am very much audible to you and my screen is visible to you. So, welcome to this Substation Saturday. Today, we will basically discuss about the dynamic contact resistance measurement of the circuit breaker. The whole session will be dedicated to this DCRM topic. Now, today, we will generally cover the following agenda. First, we will cover the history of the circuit breaker testing, where we will see in the earlier days what were the circuit breaker testings were done in the 70s and 80s timing. Then we will just give an overview of the dynamic contact resistance measurement of the circuit breaker. After that, we will generally go through the basic difference between the static contact resistance measurement and the dynamic contact resistance measurement. What is the difference between these two measurements? Following will be the DCRM graph analysis, where we will in detail tell you in each and every point of the DCRM graph that what is the occurrence, what is the circuit breaker state, each and every point of the DCRM graph. After that, we will go to the product, that is the HiSec Ultima. I'll just give an overview of the HiSec Ultima product along with its features and specification. And after that, I'll just explain two case studies which we have done with the help of this HiSec Ultima instrument. And after that, we will have the final Q&A after the presentation. So without any delay, we will start the presentation of today. Now, as I have said that the evolution of CV testing, how it is done in the 1970s, I am talking about, we generally used to do the circuit breaker timings. And with the help of the timings, we were just evaluating the condition of the circuit breaker. But we were not getting the complete picture with the help of only timing test, because we were only just measuring the timing. We didn't know what was the condition of the operating mechanism of the circuit breaker. In the 80s, I'll say late 80s, we started to do the coil current and the travel traces. So with the help of these two tests, we could understood that what was the condition of the operating mechanism during the operation of the circuit breaker. In the late 80s, after this coil current and travel traces test, we introduced that the CRM, or the main contact resistance measurement test. So with the help of the CRM, we could understood that what was the condition of the main contact during the circuit breaker in closed condition. So in the late 80s, with the help of this CRM invention, first we could understood that what was the condition of the contacts. But along with these tests, timings, coil current, travel traces, and the CRM, still we observed that many HV and extra high voltage circuit breakers were still failing. So what was the condition of what was the reason behind these failures? Now, as you know that while we are doing the contact resistance measurement, the circuit breaker is generally kept in closed condition. Now, when the circuit breaker is kept in closed condition, we know that the two contacts in between the interrupters, the main contacts and the arcing contacts, both are in closed. Now, we know that the main contact resistance is, the resistance value of the main contact is very low compared to the arcing contact resistance value. Now, because of this, when the circuit breaker is kept in closed condition, now in the CRM, what we do that we inject almost 100 or 200 ampere of current across the circuit breaker. Now, whenever we are injecting this 100 or 200 ampere current across the circuit breaker, the both contacts are closed. The nature of the current is always that it will follow the low resistance path. So in this case, what was the low resistance path? It was only the main contact. So the current was going through the main contact and we were checking the main contact resistance. But with the help of CRM, we could never understand what was the condition of the arcing contact, because we all know that just the arcing contacts are the ones who are protecting the main contacts while a fault is there in the system, because through the arcing contact the transient current is passing through, the arcing current is passing through. The main contact is the one which is carrying the rated current of the circuit breaker. So the probability of the deterioration of the arcing contact is much times higher compared to the main contacts. So that is why from 80s to 1995 we could understood that it was the arcing contact, it was continuously deteriorating. Because of that the circuit breakers were failing. Now in the 1995 with the Association of Power Grid Corporation of India Limited, Scope TNM Private Limited was the first manufacturer who invented this DCRM technology. So in the DCRM technology, we could understand that along with the main contact, what was the condition of the arcing contact specially. So with the help of DCRM, we can understand that both are what was the condition of the both the contacts, not only the main contacts, but main along with the arcing contacts. Now, the worldwide, the measurement was started in 1991. The findings were published in 1997, this DCRM findings. As I've said, in India, in association with Power Grid, we developed this DCRM product, that is the HiSec Ultima. And the field proving and the product optimization continued till 2002. So in between these 7 years, lots of analysis and lots of case studies were there. So with the help of these case studies and the analysis, DCRM graph analysis, we could understood and we could we could even predict that what was the condition of circuit breaker with the help of this DCRM signature. Thousands of the extra high voltage circuit breakers have been tested for DCRM and many have been rectified before failure. So this was the main importance of the development of DCRM. Now, if I am going by the conventional definition of dynamic contact resistance measurement, so it is a signature of changing contact resistance of the circuit breaker during closed open operation. Now it plots the variation in contact resistance, the arcing and then the main contacts. And again, while the disengaging part, the main contacts will separate first and then the arcing contact. So with the help of during CO operation, we could understand what was the condition of the both the contacts. Now again, it reflects the useful information of the contact conditions in this CO duration. It additionally, DCRM along with the travel operation will give you the prior indication of the deterioration in operating mechanism linkages. Certain mechanical weaknesses which was undetected by the earlier travel measurement can be reflected in the DCRM measurement. So that is why it is very important that you do the travel test while you are doing the DCRM. Along the DCRM and along the travel will not give you the complete picture, but with the DCRM along with the travel will give you the complete picture of the health condition of the circuit breaker. Now, if I'm just observing the difference, that what is the difference between the static contact resistance and the dynamic contact resistance. So I have quite clearly said in the earlier slide, but I'll just give an overview so that it will be very easily understandable to all of you. In both the cases, the measurement technique is same, that is the millivolt drop. We are injecting the current and we are doing the measurement of the voltage. So there is no change in the measurement technology. Now here in static contact resistance, the circuit breaker is kept in closed condition. In case of dynamic contact resistance, the circuit breaker is in closed open operation. Generally in CRM, the static contact resistance value, we are getting the single value. That is, we are injecting the current and we are doing the measurement of voltage and we are getting a single value of static contact resistance. But in this case, while the circuit breaker is in dynamic position, so we are taking the continuous samples of the voltage and current, and along with the V by I, we are getting the resistance of each and every instance of the circuit breaker operation. So we are only having a single value of CRM, but here with the help of continuous samples, we are getting a signature or the graph of both the current and the resistance. The current will be the injected current, that is the 100 ampere current while we are injecting, and the resistance will be based on the condition of the circuit breaker contacts. So this is the basic difference of the CRM and the DCRM. Now, if I am talking about the graph analysis of the DCRM, now this is a very much typical signature of the DCRM. Let me have the pointer here. So yes, this is the standard typical DCRM signature. So here you can see this is the blue line, which is the current signature. The green line, that is the resistance signature, and this is the coil current signature. So we are having two signature, two energization here, 2 times energization. That is the while closing and again then while the opening of the circuit breaker. Now, if I'm explaining the whole card here. Now, basically, what happens that from here, point A, we are doing the closing command. So first, in the CO operation, the closing command is being operated. Now, when the closing command is given to the circuit breaker at point A, the plunger of closing coil operates various valves, and the operating mechanism, that is the operating rod, starts moving upward because the close operation is happening. Now, whenever the operating rod starts moving upward, now here the graph between A to B here, you can see it will indicate the time taken for the actuation of closing coil and the control valve till the movement of operating rod takes place totally in upwards. The time taken between A to B will indicate the proper functioning of various components of the mechanism. Now, from point B to C here, at point B, the operating rod will start moving upward in this position B, which in turn moves the arcing and main contacts in interrupter housing. Now, initially the arcing contact closes at point C here, where the current is injected. The time taken between B to C, this duration will indicate the healthiness of the operating mechanism during the closing operation. Now, at point C to D here, at point C, the arcing contacts are touching with each other. So here the current injection, first current injection will start to happen. At point C, the insertion of arcing contact has been taken place. The dynamic contact resistance plotted along with the injected current indicates the condition of the arcing contacts. In case of healthy arcing contacts, there will be no abnormal bounces in the resistance values here. Now, at point D, here you can see the main contacts will close and the resistance value automatically gets reduces, because we know the resistance of the arcing contact is quite high here, but at point D, it has already, the main contacts has been closed. So here automatically the resistance is reduced. At point D, main contact will close at the contact resistance reduces further, I have said. Now, however, there may be some bounces at the time of contact touch. So the main contact insertion will continue till point E, where the circuit breaker will be in fully closed condition. That in the point E, the full closure of the circuit breaker will happen. Now from point E to point F, the settling period is there. That means the delay time between the close and the open. So this is the settling time, where you can see the graph is very much linear here in the resistance. So that is nothing but the current is injected across the main contacts, or we are only having the value of main contacts resistance here. So that is why the resistance value is very less. From point E to F, the circuit breaker remains in closed condition as per the set time delay. Now during the period, the resistance is almost constant. Here, no bounces you will observe. This period is required for the damping of the vibrations. From point F, at point F, you can see the trip command is extended to the circuit breaker trip coil. The trip coil plunger will actuate the various levers or valves to move the piston of the driving mechanism. The time taken between the F to G here, it will indicate the proper functioning of the various components of opening or tripping assembly. Now at point G, again, when the opening operation will start, the operating rod starts moving here downwards. Till opening, the main contacts at point H, from point G to H, during this position, the moving contacts start gliding by the pull of operating rod. At point H, the main contact is separating with each other, but the arcing contacts are remaining in closed position here. The signature between H to I indicates the healthiness of the arcing contacts. Any abnormal bounces during this period will indicate the erosion or the misalignment of the arcing contacts from point H to I. Now at point I, the arcing contact separation is happening, and the resistance value, you can see again, it will be very high. The green curve, again, you can see it is very high during the I. That means the opening of the because of the separation of the arcing contacts, the opening of the circuit breaker is happening. That is why the resistance is going upwards here and the current is going downwards. The time taken between the I to J, it will indicate the healthiness of the operating mechanism. So this is the each instance I explained about the each and every operation, what was happening during the DCRM. So this is how very much you will analysis the DCRM graph. Now you know the regions, and you know that in certain positions the graphs will be abnormal if the circuit breaker is behaving abnormally. But this is the basic DCRM signature. Just you need to compare this signature to your circuit breaker interrupter signature, and you need to understand that what is in what zone my car is having some abnormal readings, or it is abnormally rising the values.
Particularly here, I would like to highlight here that the DCRM is to check the behavior of the circuit breaker. What Aritra said, what Aritra explained. So, in line to that context, I would like to highlight the DCRM measurement is to check the behavior of the circuit breaker while making and breaking. First, engagement of the arcing contact, then engagement of the main contact, then disengagement of the main contact and the disengagement of the arcing contact. With the help of this graph, we can able to measure the contact gap, arcing contact tip length, contact wipe, and whatever Aritra explained, we can able to see the mechanism functioning that also we can able to operate, we can able to check. So particularly DCRM graph analysis can measure each and every point or parameters about the mechanism, about the contact travels. We can able to take out or find out. Yeah, Aritra, please continue.
Yeah, exactly, sir. Thank you for the assistance. And now we will directly go to the product, that is the Hijack Ultima. So here you can see that it is having the trolley mounted setup for the easy portability. Now this unit Hijack Ultima can do all the parameters, can evaluate all the parameters for the testing interrupter. So we can do, with the help of Hijack Ultima, we can do the CRN, that is the static contact resistance measurement. We can do the DCRM, that is the dynamic contact resistance measurement, what I've already told you in the earlier slides. Again, with the help of the Hijack Ultima unit, we can evaluate the timing, that is the close timing, opening timing, or you can give close open or open close, or even open close open. So all these commands you can execute with the help of this Hijack Ultima unit. Additionally, you can also understand with the help of DCRM graph what is the wipe of contact, the fault current, and the arcing time with the analysis of the DCRM graph. While doing the testing of driving mechanism, you can understand what is the total travel, the datum velocity, the default velocity healthiness of the damping mechanism. Additionally, you can also test the control units, and the control unit parameters are such as the coil currents, that is the trip coil and the closed coil currents, the coil voltages, along with the auxiliary contact timing. Now, I am just giving the overview of the main instrument of Hijack Ultima main instrument. So this is the power supply card along with the master earthing feature here. This is the module through which you can, this module will state the condition of the breaker. That is, it will give you either the trip or the closed state. Now, this is the travel and coil current module. So here, with the help of these modules, you can understand what is the value of the coil current. The timing module will give you the close open timing of the circuit breaker, close and open, along with the other command sections are available in the Hijack Ultima software. In the auxiliary module, with the help of auxiliary module, you can do the evaluation of the auxiliary contact timing. Additionally, we are having the optional DCRM module, which will give you the DCRM signature of your interrupt, circuit breaker interrupter. Other than that, also we are having the configurable analog inputs. Now, based on the different requirements of the different utilities, such as the, sometimes the customer asks for the vibrations, sometimes they are asking the pre-insertion resistance value. So for these, parameter evaluations, we are having the configurable analog inputs here. So this is totally based on the special requirement of the customer. Along with that, this is the DCRM unit. So in one rack,
just before going to DCRM, first I would like to highlight about the current channel. Here we can able to measure a current, coil current up to 25 ampere. This particularly I would like to highlight here. Also, we are having a short circuit protection in our equipment, so extra features we have given in our equipment. Secondly, the beauty of our equipment is that we can able to measure the PR timing. So here, as we have developed this equipment indigenously, we can able to design the measurement of the PR timing. So having a resistance of 1 kilo ohm also PR, we can able to measure the timing. So our kit can able to measure the PR timings of AI circuit breaker also and GI circuit breaker also successfully. So it's a beauty of our equipment. Aritra, you can continue for this DCRM model.
Now, if I am coming to the advantages or the features of this particular unit, so this instrument can test all types of circuit breakers, what Rahul sir said. We are having the dedicated DCRM channels for the DCRM evaluation, and the DCRM of all interrupters you can do with the single test. Now, whenever you are doing the DCRM of all interrupters of your circuit breaker in single test, so automatically the stress on the circuit breaker will be very minimum and the testing time will be very, very less. We are also giving the laptop interface with simple settings, and one particular feature I would like to highlight that we are having is the circuit breaker library is there. So where you can put the details of your circuit breaker, for example, the voltage level, what is the make of your circuit breaker. So along with this, feature, you can create the circuit breaker library for your future reference. So for example, today I am testing one circuit breaker, one definite circuit breaker. So after 6 months, when I am testing the same circuit breaker, so I don't need to put all those values here because already in my circuit breaker library, these inputs are already saved. So that is the importance of the circuit breaker library feature in the in our software. Additionally, you can also do the pass-fail limit setting here for as per your standard. After the evaluation or after the test, you can analyze the result immediately, and the report generation will be again automatic with the either in Excel or in the PDF form. We are also having the elegant trolley mounted setup, which you have seen in my previous slide. So for easy movement in substation. So the less the downtime, the more the revenue of the utility, because you are having the less connection and you are doing operation in with the single shot basis. Now, if I am coming to the configuration here, so we are having the contacts. So 24 timing contacts we are having, 12 main plus 12 PIR. So this is the configuration. So if I am just dividing this 12 main plus 12 PIR, that is the 4 main plus 4 PIR into RYB3, all these three phases. So up to 765 kV circuit breaker, that is up to 4 break per pole circuit breaker, you can connect all the timing channels and you can do the timing test of all the interrupters up to 765 kV circuit breaker in single shot basis. The commands we are having is the close trip 1 and the trip 2. We are having the inbuilt current measurement channels. What Rahul sir earlier said, that we are having up to 25 ampere coil current channel feature. The coil current channels, we are having the standard supply of 3 coil current channels up to 400 kV circuit breaker. For 765 kV circuit breaker, it can be upgraded up to 6 coil current channels. The auxiliary channels are, the configuration is standard 4 dry plus 4 wet configuration. Additionally, we can give the an auxiliary contact configuration up to 6 dry and 6 wet.
Here, I would like to highlight that in auxiliary channels also, we are having 8 channels, 4 dry, 4 plus 4 wet, and for the 765 kV kit, we are having a 12 auxiliary channels. So particularly, dry means the potential free contact and wet means with the potential contact. So beauty of our equipment is that we can able to configure this dry channel for wet also. So at a time, 8 for this 8 channel, we can able to measure 8 potential with potential contact. So this is the beauty of our equipment, that we can able to configure dry channel for wet also. Okay,
exactly. Now for the travel channels up to 400 kV, we know that the 3 travel channels are enough. So as per the standard supply, we are providing the 3 channel travel up to 400 kV circuit breaker. And for 765 kV circuit breaker, AI circuit breaker, we are providing up to 6 travel channels. So it can be upgradable as well, like the coil current. And additionally, we are having 6 DCRM channels, so up to 400 kV circuit breaker. You can test all the interrupters of the circuit breaker in single shot basis. So that is the beauty of our product test. With the single connection of up to 400 kV, you can test all the interrupters simultaneously. So that is why the timing, the test time is least compared to the other manufacturers, and also the stress on the circuit breaker is very minimum. Now, the configurable analog channel, these are again the optional as per the special requirement of the customer that I have already explained, that the different utilities are having the different demands as per their requirement. Sometimes they are, sometimes we are asking that for the vibration measurement or the SF6 gas pressure measurement or the, pre-insertion resistance measurement. So for these, the configurable analog channels are there. Now, if I'm coming into the features, so we are having the 6 DCRM channels for the current and resistance. The current injection of each and every channel is 100 ampere DC. So with the each DCRM channel, we are injecting 100 ampere to all the interrupters up to 400 kV circuit breaker simultaneously. So this is the you can say one of the prime features of the Hijack Ultima. The range is quite high, up to 8000 micro ohm we are giving. The measuring speed is 50 microseconds at 20 kilocycles. So you are getting the complete picture with 50 microsecond interval in the DCRM measurement. So that is how accurate and that is how good the measuring speed is. Within 50 microsecond interval, we are giving you the DCRM, we are giving you the indication of the circuit breaker contacts. The measurement is DCRM in resistance is instantaneous along with the current, and also we are having the battery status feature here. The power source, it is having the inbuilt power source with the low maintenance SLA battery. What Rahul sir was said, that it is having the MCP protection to save the battery in the DCRM unit. Now, what are the advantages of the 6-channel DCRM? If I'm saying the setting is only once, so while doing the DCRM setup, you need to do the settings only once. You need to do the channel settings only once. And with the help of that, you can complete all the interrupters of the circuit breaker in single shot operation. So you can analyze all the interrupters of the circuit breaker simultaneously. On that, the on-site result view and analysis is possible. So immediately after the analysis, after the DCRM graph, you can create the report in either Excel or in PDF form. The less connection and the one connection time, that means we are doing the connection only once. So that means we are having the lesser testing time. So the less operation on circuit breaker, I have already mentioned that the stress on the circuit breaker will be minimum and the system downtime will be 1/6 of the earlier, because earlier what was the practice, that we were doing the DCRM in single interrupter. After that, we were again doing the disconnection and we are doing the connection of the second interrupter. Like that, we were doing the DCRM in earlier. But nowadays, the main practice is that we need to do the connection of the all interrupters simultaneously. So the timing, the testing timing will be very, very less. For that, we are having the more availability of the power, and the revenue for this will be more of the utilities. Now, we are directly going to the case study here. So I'll explain two case studies here. The first case study is the circuit breaker, 400 kV SF6 circuit breaker it is. So it was commissioned in 1997. It was generally controlling the bus reactor. The circuit breaker had given about 8 years of service. So in 2005, we did the DCRM. So in between that, almost 1400 operations it had been done. Now, while we were doing the DCRM signature, so this was the DCRM signature of the healthy pole. So here you can see that in the earlier slide, what the DCRM signature was, the same was that of the same is that of the healthy pole. But here in the suspected pole, we are observing some spikes. So this is the abnormality of this suspected pole here. Now, what were the observations after the overhauling of the interrupter? We could understand that the moving arcing contact was found D-shaped and had expanded like this one. This is the D-shaped arcing contact. One counter of the head screw of moving contact assembly was found loose. The PTFE nozzle of the moving contact assembly found cracked, and also the scratch marks were seen in the moving contact, like this one. The scratch marks you can see here. So these were the abnormalities. So coming to the case study 2, it was done in Jalandhar in February 2007. In Chamera 1 type, it was a type A circuit breaker, and you can see that there are some abnormal spikes. Spikes are coming in the DCRM graph, especially after the arcing contact insertion. So during the main contact insertion, we are observing these abnormal spikes here. Now, what were the observations made after the overhauling of that particular interrupter? So these were the observations. The operating drive of the pole was opened, and in the bottom seal rod of the operating drive found opened from the bottom seal assembly. The bottom seal was not properly fitted and got opened during the operation of pole. So that is why, because of this, that the proper closing was not happening, and because of that we were observing these spikes in the DCRM signature. When the circuit breaker chamber was opened, the Allen bolt of coupling piece of camera side interrupter was found loose. The Teflon nozzle of this chamber was found damaged. Now this is the PTFE nozzle here, so that you can see the heating marks on the PTFE nozzle here. So because of these, the abnormal spikes were coming in the DCRM signature. Now, when the rectifications were done, the Teflon nozzle actually was replaced and the bolts were tightened properly. The end result was that the travel problem of the pole got rectified. So earlier the travel signature were like this. You can see the abnormal is here. These spikes, there is the downfall in the graph here. So the travel graph is not proper here, along with the main contact insertion position of the DCRM signature. But when this Teflon nozzle was replaced and the bolts were tightened, the travel graph here was quite solved here. So it was not abnormally, it was going down like this in the like the earlier graph, but there were some improvement in the DCRM signature, you can see here, but still the bounces were again observed. But somehow the improvement of the both the DCRM and travel graph we can observe. This is generally where my presentation ends. Now, for further inquiries, you can free to contact regarding the sales and the product information on marketing@scopetnm.com. For the regarding the after sales related information, you can contact service@scopetnm.com. For technical queries related to the circuit breaker and the DCRM signature, you can contact ps@scopetnm.com, and our website is www.scopetnm.com for the product overview. Now,
concluding here, I would like to add some more things, particularly some of the questions we have received. The people are asking about the PIR. So PIR is a pre-insertion resistance, particularly in 400 kV circuit breaker or 765 kV circuit breaker. PIR pre-insertion resistance are available. In our equipment, we have given the facility to measure the contact timings of the pre-insertion resistance also. So particularly in AIS circuit breaker, on an average, the resistance of the PIR contact is 250 ohm. But particularly in GIS circuit breaker, the end to end, the PI resistance is approximately 500 to 600 ohm. So in our case, we are having that facility that for the AI circuit breaker also and GIS circuit breaker also, we can able to measure the PIR timings. So I'll answer the one of the questions. Secondly, about the DCRM graph, particularly DCRM graph. So what is the DCRM? Particularly in a static contact resistance, when circuit breaker is in a closed condition, contact is got inserted, then only at that time we are injecting a 100 ampere and we are taking a milliwatt drop. So that is a simple measurement. In DCRM, what we are doing, we are injecting 100 ampere while making and breaking of the circuit breaker contact. So it's a very important phenomena. And here in a DCRM phenomena, what we are doing, we are again checking the behavior of the circuit breaker while making and breaking. What I said earlier, that while engagement of the arcing contact, engagement of the main contact, and then disengagement of the main contact and disengagement of the arcing contact. So this phenomena we have to observe. So what Aritra said earlier, that what is not visible, that we have to see, that we have to observe, that behavior we have to observe during this DCRM graph. It's like a ECG of the heart. So in DCRM that we are measuring. So particularly what I said in the DCRM graph. Now DCRM graph is not in front of me, but what you can able to measure the contact gap. So contact gap we can able to measure, contact Y we can able to measure, and contact arcing tip length we can able to measure with this DCRM graph. And with this measurement we can able to save the graph by doing a trend analysis. So by scheduling the testing of the circuit breaker and doing a trend analysis, we can definitely save the circuit breaker. So it's a very important phenomena. Some of the questions about the linkage ratio. So what is the linkage ratio? Actually, we are connecting a transducer across the mechanism of the circuit breaker, and we want to measure the contact travel. So particularly for each and every breaker, there is a from mechanism travel to contact travel, some linkage ratio is there. So this linkage ratio must be provided by the circuit breaker manufacturer. So for this ABB circuit spring pneumatic, it is one. Particularly for CGL, it is 1.64. So particularly means as per the manufacturer to manufacturer, they are providing this linkage ratio. And if you can separately write to us, definitely we can also able to provide the linkage ratio to you. So linkage ratio is very much important for measurement of the actually contact travel contact wipe and arcing contact tip length. This is an important thing. Okay. One more questions I can able to see about the dry and wet contact. So it's about the auxiliary contact. We can able to measure the timings of the dry contact also and wet contact also. Dry contact is a without potential free contact, and wet contact is a with a potential contact. So we can able to measure the timing of the both dry and wet contact, and in our equipment also we are having a facility that we can configure this dry channel for wet channels also. I have explained about the linkage ratio also. So that linkage ratios question already I have explained. So this about the DCRM. If you are having any doubt, whatever the Aritra given our email ID, you can separately write to us. Our phone number is also mentioned in our this presentation. We'll provide our presentation to you. You can separately write to us. We'll definitely answer each and every questions and each and every doubt. Okay. So this about our this DCRM presentation. It's a very important phenomena of DCRM we have covered here. Aritra, thank you for nicely covering each and every point of the HiSec Ultima and DCRM Ultima. And thank you for patiently listening our presentation.